Hmm. Yeah, I have a new idea, which is too interesting to not try. Let's put the new idea in a new file. My new idea is as follows. I really have to put a little window over this, or I will be distracted like hell. Launch control. Let's put it at this size, and now we put the layer on top. Okay. Include IO stream and main. Well, let's calculate the factorization of that. I want already to go to possibility of using really big numbers. Okay, now the idea. My idea is to do, I think, ceiling. Okay, that's do ceiling, right? Ceiling ceiling square root. Nope. I need a ceiling of it. Actually, I can bring this M outside, I think. Minus M. Yeah, let's use this. Next. Do we have an L, and I'm going to calculate the next L. Let's keep L. Let's see. I still have to calculate M as well. M is the ceiling square root of N. And then we calculate hello bread. L. Yeah, dude, what the fuck? I said hello bread. I don't know. Either your video is lagging like hell, or yeah, maybe if you tune in. I was at 5 minutes, or maybe if you just tune in, you begin at the beginning of the stream. I don't know. I've been streaming 5 minutes, so yeah. There's this YouTube sucks really, but in terms of chat, because there is a very often, I think, a delay between the chat and the video of around a minute, more like that, which is indeed not very nice. Well, what I'm doing is I'm trying to factorize n, which of course is impossible, otherwise someone else would already have done it. But I just have an interesting idea. Yeah, if you're interested, then type it and I'll explain to you. If you have been here yesterday or the day before, then you probably already saw that. So now I'm just going to do the new idea. The new idea is that I take L, the old L, and add M. Let's make a square as well. A square function. The square of L plus, I'll use LE, plus M minus N. And then the ceiling square root of that. And then squared again. And then adding n to that. And then taking the ceiling square root of that. And subtracting m. I might as well work with what I used in my previous program, namely q, which is equal to li plus m, I think. Yeah. So I'm setting q here. Let's say we set qi to m. And now we print out what q is. And then that's no longer needed. And then this becomes, well, the new q. But I want to kind of remember what the previous q was. So let's say this is I plus 1. Ellen, hello. I'll type it because of the delay between the video and the chat. Number. So now qi is li plus m. And then we don't have to subtract m here. It just gets a little bit simpler. It looks a bit too simple. Gotta be kidding me. Well, okay. Suppose n is a square. If n is a square, then m here is exactly the square root and the factorization of n. So q is the exact square root of n in that case. Then we square it, we get exactly n. Though this is 0. Therefore the ceiling square root is 0 and the square is 0. And the ceiling square root, sorry, then we have to add n. So that is n then. And then the ceiling square root gives m again. and therefore qi plus 1 equals qi. So we have not made any progress. So we do while is larger than qi. Well, then I have to assign, and then we're done. I have to assign qi again to be this. So maybe I should begin with that then. qi plus, this is ridiculous, but okay, plus 1. Nah. I begin with q, and then I do qi is q, and then we calculate that, and then I do q is qi plus 1. Maybe I have a variable too much now. Feels like it. Well, I don't know. Let's implement my square. I might as well call this number. Number square. Here we have, call this square, sorry, call this number as well. And this is a number. Why is my heart in the way? What Ellen said. Do you recommend CPP? Heart probably 2. Me? I work with Python. That's a difficult question. That's a difficult question, Ellen. I think you foremost must just like it. So if you start coding in C++ and you think, oh my god, this is like the language I want to use, then yes. That was my experience. I had coded already in C for a long time, and then I started to learn C++, and I was like, wow, this is so much better. From a commercial standpoint, I don't think so. If you're not super thrilled with the whole speedy thing of C++ and the complexity and the flexibility, then I think Python is a very good language at the moment. It seems that all the artificial intelligence, machine learning stuff is using Python, isn't it? Maybe there will be a shift towards C++ to make things faster, I'm not sure. That's definitely not what I wanted. Oh, I'm calculating the wrong thing. Compiling the wrong thing. See all sorts. I could have made no typos. That would have helped. Okay. I have to do this a little better, right? I want to print it every time anyway. That's kind of stupid, I think. That this while, this expression here does not anymore have access to these declared variables inside the loop. Ridiculous. Shall I make it a for loop? Even then. I'm gonna keep this on. Then I cannot test it. Or I can just break out of it, make it an infinite loop. We can push that inside here maybe. Yeah, well, it still won't work because then we don't know what that is. So I have to declare that outside of it. Oh yeah, and then I have to print these values inside here. Seems to work, but it just increments it by 1 every time. So maybe it doesn't help me at all. I guess I'll have to test it with a larger value. But this absolutely helps nothing. Let's print a factorization as well at the end. So I can print n is n equals well, x times y, and then we have to calculate x and y. Having Q. Q squared minus n. K is no good MP square root of the square of q minus n. I think that works. And then x is q in a minute is qi. I don't have that anymore. The moment I break out of it, oh, I still have qi plus 1. So we can do here q is the last one, and then break out of it. At least then we have q. The x is q. Let's make x a smaller one. Doesn't matter if I do it like this. Swapping x and y now. What's correct? Let's try another one. The one that I know, 209. Let's hit in 1. Yeah, and then a large number. I don't know. Let's just try something. It's a bit very large, but the question is Q growing faster than 1 at a time? I think it is. Is it finding the answer, however? It is finding the answer. Oh, this is impressive. Let me check if that's correct. Yeah, of course it is correct, but yep, it factorized it. Pretty awesome. So with the with the queue of this, did it use 16 million steps? The previous one used 16 million steps. So now I want to know how many steps it used. That should be significantly less, hopefully. So I need to have an iteration count. Unsigned int iteration. Start with 1 because we begin with doing this. Or is that nonsense? That is nonsense. Let's start with 0. And then increment iterations here. And I'm printing, let's say, number of iterations. Maybe I should just print iteration. No, then we start with 0. I don't want that. It's not printed. So it's printed at the end. Iterations is iterations. No, this is not helpful anymore, I think. See how fast it is if I just do it like this without printing. Pretty fast, but I should have printed Q as well. Oh, this is almost the size of Q itself. Damn. Try it. And of course we could have found this in a lot less than 28,000 steps by just trying to divide it. So that's such a bad algorithm, this. Nope. Yeah, I had hoped that the queue would advance faster than this. Oh well. Okay, I'll do one more test. So we time this. It takes 1.96 seconds. And if instead I would use the other method where we just increment Q one by one. And then I need my perfect square tester. To test a perfect square I have to do one square and one ceiling root or root, which is then twice as fast as this. But nah, you know what? I'm going to print the difference, the increment in Q. Let's say print that here. My trick is not helping. It's just incremented by one. So that means that it's about twice as slow as what I had. Yeah, super bad. Super bad. It is so weird for me that it just seems to be not possible to solve an equation that says for which value of this variable is this formula a square, a perfect square. That there is no way to solve that. Isn't it like weird? Yeah, I should quit with this. Let's go to the thread save test suite. Maybe I did make changes. I'm working in this one. No, even if I did, then I pushed it already, I think, to GitHub. New commits. Modified Contendo. Oh, huge changes. Okay, I'll explain what I'm doing here. The idea is as follows. If you have, say, a class, struct B. B is a base class. No, B is a struct, arbitrary struct. Is that correct? Yeah. Some random type. Why am I even using this struct? Now we have a function that takes B by, let's say, pointer. Now let's say const pointer. Then I have a B1 and a B2, and then we have a B pointer, which is B pointer, and we have a B const pointer. Then I can call fbp1 and I can also call fbp2, because fbp2 has the same type as the argument of f, to be const pointer. Yep, so we can just pass it. But I can also pass a b pointer to f. Since last time I booted, my middle screen is flickering. At least I see this title bar flicker on and off. Sometimes. Scary shit. Yeah. Okay, so it is allowed to pass a b pointer to a b const pointer. Yep. And it is not allowed to have another function, g, which just takes a b pointer. Let's put it up here. No, flick it again. And I try to pass both of these. Now we are allowed to pass BP1 still, because it's just the same type. But we are not allowed to pass BP2, because you cannot pass a some type const pointer to the same type pointer. Yeah. And then we realize that that mechanism looks a lot like inheritance. So now I'm going to do the same thing, but without const. So in this case, we are going to make a class A that is derived from B. And I'm going to make a function f that takes a b. Let's take const reference and void g. Let's take a const reference. And then I'm going to say that the A here plays the role of the non-const thing. And the non-const thing here is, well, these things, that this is no longer necessary. Let's move these up there. So let's make an A, which I call BP1, and a B, which we call BP2. And then I can call F BP1, and I can call F BP2. Exactly like here, right? Why is that the case? Well, the BP1 is an A, and we can pass that to the argument of F, which takes a B, because B is a base class of A. We can also pass it to G, which just takes the A. But we can also do this, because G takes A, sorry, yeah, G takes an A, therefore we can pass BP1, which is an A. But we cannot do G BP2, not allowed, because you cannot pass a B, the base class, to an A. L, unless you add a constructor for that, but we're not talking about that. No explicit conversions. So yeah, super much the same thing. Don't you agree? So that brought me to the following idea. If I have some class, that has a constantness in it by design. So let's say we have a struct, well, I'll make it a class even. The real deal, foo, looks like a super serious class. But foo has the ability to make changes, so it's non-const. Changes stuff, something. Not itself maybe, but maybe something that it points to, say. And then I say, yeah, that's all nice, but now I want to be able to talk about a foo that does not have that ability to make changes. Then you would think that maybe I have to talk about foo const, and then make the member functions of foo such that only the non-const member functions make changes. So we could do void make change, and then there's a non-const function, and then we have read stuff which does not make changes, and we make that const. Public, of course. Then if you have a foo const, then we can not call make change, and therefore we have a variant of foo that allows us to use it as a foo but not make changes. We can only use it to read stuff. However, nobody stops you from making a copy. So let's say we make a foo copy. I'll indent this. Of foo. And I have to admit that in my real code, I therefore did forbid this. Is no way to make a copy, but I'll have to explain why this is a problem. Now foo is not const. So now I can do foo copy is not const. So we have a const foo here. But I can pass that to foo copy. Sorry, I can pass that to the copy constructor of foo if it exists. And then we have a foo copy, which is non-const. And then I can make changes again. And that's super ugly. We don't want that allow that, because yeah, it's suddenly our constantness is gone, as it were. And then the only way to avoid that is by disallowing creating a foo from a foo const pointer. So you would have to do foo the const foo, the copy constructor const reference is delete. So now we don't allow this line here. But it turns out that to be too ugly. And in my case, I really found out that I do need copy constructors. So we do have a copy constructor, and this is therefore allowed, and everything breaks down. So instead of making a const foo our read-only thing, we need a new class, and I call that const foo. And then this is not allowed. Yeah, so you cannot do this. You cannot make the foo copy, therefore you cannot make changes. However, if now we want this to work again, so we have a function, let's say f. Let's look here. So f was the one that took a const thing. So now we have f const foo, const reference, and g takes foo, const reference. Really, my monitors are blinking. I'm scared. What's the temperature of my everything? Oh, pretty low. I don't know what's going on. It is not good. Const foo. Sorry, like this. That's one, and then we have a foo. Foo 2. Yeah, then I can call f with both. Well, wait a minute, this is not possible, but I want to be able to call f with both. And we want to be able to call g with foo 1, but not with foo 2. In other words, the exact same construct as if we did this thing here. In other words, we must have an inheritance, or we could have an inheritance like that. Now both have a copy constructor. If you have a foo, you can make changes, and you can also read stuff, because that's just a member function of the base class. And if you have a const foo, then you can only read stuff, because the whole interface is not there. And we're simply not allowing to construct a foo from a const foo. And then everything works. Right, so I just spent, I don't know, half an hour to explain this. And I'm already working on that right here, but at least then now I hope you can follow what I'm doing. What I had was an unlocked base, where I tried to... An unlocked base, by the way, is a class that wraps a base pointer, like that, so like this. Which then gives access to the underlying pointed pointed to base, which is unrelated to unlock base. I mean, this is a one class, and base is the base class of some custom class. But if we can call PTR on it, and then we get directly a pointer to base, and we can therefore make changes to whatever that is pointing to. And as you can see, what I had, this is now deleted, but what I had is that if unlocked base is const, then we can only get a const pointer to that base class, and if unlocked base is non-const, then we can also get a non-const pointer to that base. But that broke down because then I have to disallow the copy constructor of unlocked base. So now I switched to what I just explained, and I did split it up into classes. The const unlocked base, which is now the base class of the unlocked base. And then we can just add a copy constructor to both, and everything works much better. But what is required, I think, is to test it, because I don't have a test, and this is really, well, it's part of the thread safe Git submodule. It just should work. I can't have it that my submodules have bugs in it. That would be the beginning of everything collapsing. So I'm going to do a commit. See, this compiles, I suppose. Does not compile. What the hell? Yeah, it's not related to thread safe. I want to test the thread safe thing first. I'm just going to do commit, I think. Add const unlocked base. Git push. And then I can go to the test suite of thread safe. And then we can pull. We can also run autogen.sh. It should also grab it. That grabs all the submodules. Under quoted definition, and that's in file that I am not maintaining. Hello, Crazy Marcus just joined. Yeah, I just finished explanation without coding. I just explained what I'm doing the last 20 minutes, I think, at least. You missed it. That's why I don't like explaining things also. But maybe the few people that were there are still here. Okay, we grabbed it, so now I can build the test suite. And now we see that the test suite immediately fails already. No member m read write mutex. In thread safe unlock the base. Well, I switched back to my previous project, Crazy Marcus. I just explained how there is a similarity between inheritance and how const pointers and non-const pointers are allowed to be converted into each other. And I need that for my thread safe unlock base. Now I have to fix the test suite and then add tests so that we are 100% sure that this works. Unlocked. How on earth did I break this that much then? I just gave up. I started with that, but I had a new idea and didn't speed up anything at all. And I think I should just stop with the factorization because it's going nowhere. I think I renamed it to pointer maybe. No, wait, this is the reference. Read-write reference class. Here it is. This is the one. I guess I should just call mutex instead. And then it works in both cases. Because the unlock now can be two different classes. Also a reference, which contains a reference, but also has a function mutex, which then returns a reference instead of the thing directly. That's it. So I have others like that. Like this one returns private mutex. So I might have code that still accesses that directly. Or not. Let's start at the top. Comment. No. It seems I already got rid of that because I have not been testing the read-write mutexes in the CPP graphics project. And there is one more though. I have the single threaded stuff. I think that's just this thing here. It returns an int, so it doesn't have a mutex. One thread is called. So the thing doesn't even have a type, and I should not be accessing it anywhere else. Then now can I compile it? Still not, of course. Oh, the same thing with the reference count. No, wait, mutex is a private member of read-write ref. That's interesting. No, go mutex. Read-write, it's not private, it's protected. But okay, same thing. And then we have this one is also protected. Maybe this one works because we have friends here. And then I do not have a friend for the struct that is trying to access the other one. The other one being... there's lots of friends. There we go. Let me look at the error again. Retext is a private member. What? Member is declared here. Oh yeah, constrained by implicit what? Implicitly private inheritance here. I think there's a public missing here then. Const unlocked base is privately derived from reference type. It should be pop. No, wait. Nah, whatever. No proof, direct proof, but I think it's pretty obvious that I just forgot to type it public here. Yes, let's skip that error. So we go to the next error now. No member named mref in, also unlock base. So maybe I also have a function on that. Instead of directly accessing mref, we have to access. Here's the mref. Yep, we have to call either increment or decrement ref instead. So in this case, increment ref. Oh, that's decrement. I think we got everything now, right? Yeah. Increment ref is private. A private member of thread safe const unlocked base. So again, I'm missing public here. Seem to forget that every time. No, this is nonsense. This is just an implementation of in whatever. Const-read access. That's public. Let's go here. Increment ref is a private member of const unlock base. Let's run ctags. That's very private, but it should not be private, of course. Kinda depends who calls it. Well, now I think about it. It used to have access to mref, directly access. So it should never be a problem to call this. If we had access to mref, then we have access to increment ref. So this is not the problem. But maybe the other one is the problem, this one. You did not have access to this class. And that is the const unlocked base class. Yeah, there's no friends here. There's a tough decision. We should just add a lot of friends or not. Let's try to figure out. I think there's a balance between decrement ref and increment ref, so that's not very interesting. Let's just look at increment ref. The calls happen from const read access, write to read carry. Access const. That's also access const. And then one thread access const. So all the const accesses. Now we have the explicit problem in const read access, correct? Yep. So then we need a friend for const read access. Like that. In am I around? Like the problem is that I did split up unlock base into const unlock base, and the friends are here. These are the actual friends that we need. I shouldn't be adding it like that. If I move this to the const unlock base, then that might work, I suppose. Or I already moved the C-red there, so we don't have the using. Now what is the problem here? I have this friend here. So read access is which type is it? Damn it. Const read access. That is a C-red type. And the other one was Const read access. That is a serial type, if you ask me. Pretty sure of that. Thus, if I go to const unlocked base, that should be the type, and I friended it. So this doesn't make much sense. It should already work. Yeah, I was adding this, but this is not good. I'm afraid I'm not getting this error. Increment ref is a private member of const unlocked base. In instantiation of member function const read access. Custard here. In instantiation of member function read access. In instantiation of function template specialization or write access. No declared private here. Etex is a protected member. It's a new error. Might be the same thing. We are not a friend. Why are we not a friend? So the class const unlock base should add as a friend whatever class we are in at that point, which is const read access. And I think that's this. This should be const read access. Or this one then. Well, those are the access types. Specialization const unlock base, const read access type. I don't get it. Let's postpone solving this. Going to make this public. Probably getting a lot of other problems out. There you get the same thing for mutex. Unlocked mutex, also constraint access, or also, yeah, also constraint access. Which mutex is it? Of read write ref. Yeah, mutex in read write ref. Glad protected here as well. It's like literally adding a friend here for absolutely everything cons read access. How is it possible that cons read access cannot access this thing? Show me that again. Mutex is a protected member of read write ref. Yeah, read write mutex. Read write ref. It's a friend, so I have no idea why mutex cannot be called here. Unless it's not a friend, because cons read access was changed and doesn't look like this declaration anymore. Yeah, seems unlucky. Nope, just template class unlocked struct cons read access. No, maybe it's the same thing as here. That for bug in the compiler reason we have to add the namespace in front of it now suddenly, which wasn't needed before. That looks like to have worked. Ridiculous. Don't know, can I remove my fix me? Because now we are friends. Yep, that was it. Well, at least I am. Well, what did I want to say? I think I had a reason that it took so long, because it was not easy to find. And basis private member. Declared private here. And it's being called from what? Yep, totally private. And base is private, so we're also missing a friend then. Maybe it's the same kind of thing. There's a friend here, that should work. I don't know who's trying to access Embase. Let's figure that out. Base is a private member of const unlocked base. In instantiation of member function thread unlocked base PTR requested here. The one that is trying to access it is the base class, unlocked base itself. That must be protected now. Yeah. Gotta wonder, you know, if this is protected, and now I have to make that one protected, then why do I even have this accessor? Might as well access Embase directly, or what is the thought about that? You have a pointer here and a pointer there. I guess that pointer selection is kind of automatic, but doesn't give much safety. There's a parenthesis missing here. Yeah, I don't know. Yeah, and anyway, yeah, it kind of makes sense that this must be protected. But I don't understand why this one's protected then. Shouldn't it be public? And since it isn't and it still seems to work, that means I'm having friends probably because I want to access. Oh, these are public. It's a mess. It's a mess. Error const the cast from const unlocked pointer. I hate this compiler. I want to read it as from unlocked const pointer to p pointer is not allowed. In instantiation of function template specialization const unlocked base. Is that here? Maybe I'm trying to cast too much at once. Unlocked is, I think, derived from T, which should be derived from base. Well, that is like a given here even. T is derived from base and unlocked is derived from T. It's in here. And this is a const unlocked base, which does store non-const pointer to base, but doesn't give non-const access, so that's okay. That's why the const cast is being done. But maybe I should first cast it to a base const pointer and then use the const cost only to get rid of the const. Yes, okay. Yeah, well, this compiles. So now I need to extend my test suite, I think, or let's first run the test suite that we have. See if everything works at the moment. Test that we have, that tests, and I had something here. Well, prints 43, so that seems to have working also. Let's have a quick look at the diffs that I made now. Needed a public there. We need not to cast everything at the same time. It's not allowed with the const cost. The derived class needs to access and base, so that must be protected. I added a public there. Well, that was also temporary. Let's try removing the public first. And here I have, must use increment ref and decrement ref instead of accessing mref directly. We must call the function mutex instead of accessing the mutex directly, which I had not tested, not even compiled for the read-write lock. Hence that was not captured before. I'm missing parentheses there, and this is just plain weird, but apparently we need that. I'm gonna look for all the other friends that look like that. PRS not found. Too many threads. Yeah, no, these don't look very good either then, no? I have a shitload of friends that don't have namespace in front of it. I guess I could check if I even check it by commenting that out. So does this friend work if I remove it? Shit, you know, that's what I mean. I'm not even testing it. It seems highly unlikely, I must say. Am I only testing read-write logs here? Oh, I am. I have to undefine this to test more. And then here's a shitload that's commented out. It's also interesting. Yeah, this is a read access type, so you cannot write to it. Even for the primitive case, you still get a const reference. Sorry, yeah. X is a const reference here. So that should not compile. And since we're writing to it and it says write access, it just has to look like that, no? Maybe I should use access here. Write access, what is access? Access is a red. Oh, wait a minute. Read access, test read write. You can take a write, you can construct a write access type from a read access type here. I'm not sure if that is possible in this case, indeed. That doesn't work. Theoretically, I guess it should be the same thing. As in, why would I need to change the code? Does this not compile? That does not compile. Magic constructor for initialization of access. Candidate constructor, implicitly copy constructor. No, implicitly move constructor. No. Const L value reference to type what, aka access, cannot bind to a value of unrelated type. Const access. So no difference between red and C-red, because this is acting like a C-red then. Thought I have my C-red is access const. The red is const access. I should be able to construct an access from a const access. If I explicitly do that, why not? No matching function for call to. I think it's kind of strange. Yeah, here. Access derives from access const. Oh, wait. What? Returns a const pointer and a const reference, so that's just a read access. And then const access derives from access const. What's the difference between those things then? Data, unlock data type const reference something. Unlock data const reference. Geel star. It's the same thing. So we can create a const access from an unlocked type. And both give a read access. So there's virtually no difference at all between the two. You gotta wonder why even this one is here. It's probably the same as constructor of access const, isn't it? Works. Apart from the explicit, well, this one takes a const reference. Here we can take also a non-const reference. But I don't want to make a difference anymore between const and a non-const unlocked. Yeah, so the use of the const is the difference is that this thing then can be constructed from a non-const reference of unlocked, but I want to switch to having an unlocked and a const unlocked instead of having just unlocked and then using a const one of that and not, as I showed in the beginning. It just doesn't work. In the end, this should just be using the same constructor as the access const, as the base class. I'm not sure how that works though. Let me do a redo. We're having this. Do I need to repeat a template? I guess I do. So I could do maybe template using const access const. I think that is the same thing. So then, yeah, the comment says, it must be a non-constant unlocked. So that's the reason why. I want to see what goes wrong if I do this. Cannot template a using declaration. No. And then we have the problem that now I want to allow constructing an access from a const access. So that would be a copy constructor. So this is then a read type, read access type, which should be allowed to be converted to a write access type. This is the write access type. And it doesn't have any members of its own, so we just have to construct a base class, and we only know this, so we just pass that to the base class, which means that we are basically accessing the copy constructor of access const. And I'm afraid that it doesn't have that. At least this one doesn't. Why does it not allow that? That's also a good question. Yeah, it's not that easy, is it? It is not that easy. There's a word require recursive lock, and we don't have that. Maybe I should only allow a move, because I really don't want to add a reference count for this. Let's allow move. Can't copy it because that would require a reference count, in that if we destruct this object, the other thing still has to be locked. Yeah, so that's not working. Would work if mutex was what's it called? Recursively blockable. Would also like to have. Wait a minute. This is what I want. Const access. No. It's the other way around. Sorry. It's not what I want. I could use that, however. It's kind of like a const cost. So this thing could be allowed to return a random object. No, I would need a cost. I can add an operator like this that returns a reference to an access type. So much like this, except that access doesn't exist yet up there. We will first have a look at the move. If I move access cons to this one, then we call the move constructor on this one, which calls the move constructor of access const, which is this one, which copies the pointer and then sets unlock to null pointer, causing it to not do anything at all. If it is destructed, I bet. So that would be, yeah. This is false, doesn't do anything. So that's looks totally correct. Let me try that. So then I can construct a write access from that, but then this is no longer true, I think. Is write locked access. I just moved access, so I should not call is write locked on it. What does is write lock do? Nobody knows. Access unlocked? What the hell is that? It's probably a hack to get the underlying unlocked thing. And then what the hell is write locked is probably always true for a primitive case. Just read write mutex. Here's write locked. Lock access. Is locked at all. Yeah. So that still works. Cannot bind the value of unrelated type red Oh, that's the same thing. Below, a little bit lower. Standard move. No matching function for call to func read and then write. Candidate function not viable. No known conversion from write access type to read access type reference. Ooh, that's bad. Hi, post. Access should be derived from const access. This is the base class thing. So of course I should be able to pass a const to its a function that takes a base class reference. Is it not const access? No, it's access const. We are derived from access const. Why? I mean, this is the C-red type, right? C-red should be equal to access const, I think. It's not. Okay, well, my mistake. I don't have a C-red at all. Oh, that's not how it works. No, const read access type. Const read access type is access const. The read access type is const access. So access must be derived from const access. And it is not. Let's change that. Look like completely swapped. It is not even needed anymore. Const access is const access and access const are both member functions. Sorry, base clauses. I'm so confused. This is a watt cost. So now I'm using a standard move for this. Could have used watt cost, I guess. Cons access. Yeah, that's a reference then. Access constant. That's still weird. So many changes. Use undeclared identifier base. Meant access. And run test. Zip. Let's save test. Segmentation fault. Is locked is called on a non-existing thingy. And primitive mutex. What is this? This is 0. Is write locked is called on this. Yeah, we cannot do that. That's what I said. Is write locked. Is write locked on A. A was moved, I bet. Write locked access. Access was moved. You cannot do that anymore. So let's not do that. Then is right locked. Rather look for a standard move, I suppose. So read access here was wrapper. Actually, that should still work. Right lock wrapper. Why not use that? Oh, because we don't have that. Okay, not here. Okay, well, make. What? Is read locked wrapper? It's not working after all. Why is that? Oh, yeah, that's pretty nasty. Well, yeah, if so, nah, that's too nasty. Shit. The whole move thing is just not working. That destroys the red, and we don't want that to. Can't do that. No move. This must be allowed, and the move is not allowed. Instead, I'll use a watt cost, I think. And the watt cost is watt cost takes a const access const reference and returns an access const reference. So it must be a reference, obviously. Cannot create a new object. Let me then use the equal thingy. think that's much better if it compiles. That works, yippee. Okay, and that still works. So now I have to remove my move constructor. That was not a good idea. What else do we need? Let me try removing that that public here. It's gonna like line 600. I think that is no longer required. Here it is. Increment ref is a private member. Constraint access. Custard here. Private member here. VI. Yep. Constraint access. Right, but it's again very weird because that should be this type and we have a friend. I added a friend for it, so why can that not access it? What the hell? So apparently that friend is then doing nothing. So I delete this friend, then nothing changes. Now you can suddenly do have access because of the friend. Here, that's const read access. Yeah, I'm a brute, boys bunny. But the friend was doing something useful, so maybe we should uncomment it again. I can find it. So the friend is doing something. It's giving access to can't see that here. Unbelievable. It's giving access to constraint access. But if I remove the public, then suddenly I have no access anymore from here, which is constraint access. So the friend is a friend for constraint access. Because we needed it in which function? I think this one, pointer or something like that, or what? Definitely constraint access anyway, right? I mean, that's what I said, constraint access. And now we don't have access, being constraint access, to another function. This is so unbelievably not possible. Hilario, yeah, I started to work on my main project again, so I'm not working on the factorization anymore. But yes, I was using a boost multi-precision, which is I think built up on top of the GNU stuff. Tired. Should go for a walk. Everything hurts. I should spend my time on different things than this. It is ridiculous. This is not worth my time, right? I mean, anyone's time. We need an AI to fix stuff like this. This is so annoying. Why do I not have access here? Possibility is that C-red is a different type in this particular case for some unknown reason. In other words, if I add explicitly of the friend that I expected. Const read access. That was the one that needs access at right at this moment. However, that is a template, isn't it? It's a template. And then, well, let's be paranoid and add that as well. Type specifier required for all declarations. What you're talking about, man? Const read access was not defined yet. I suppose that's forward declared. Okay, what am I doing wrong here? Strict. I guess I forgot the struct. Okay. Yeah, it got compiles. So apparently this CRED is not the same thing as that. At the moment that it goes wrong. Anyway. Yeah, I cannot do that because I don't know what unlocked is. At least. The only thing I know is the reference type. That's nothing. Just unlock base. For unlocked, we need T and a policy mutex. I have the policy mutex, so we don't have T, but we have the policy mutex. Yeah, that doesn't help. No. Difficult to make. So here I'm trying to access it from const access, const read access with unlocked being, and it should say that here. I guess this. Yeah, this is the type. So this is my unlocked. It's unlocked base. Now, to test this, I need B. I need B and whatever its derived clause is. That will be A. Good. So I have an A and a B. No, this is unlock base test. I wasn't testing that, was I? Is this unlock base test? It is unlock base test. Oh, okay. So let's put AI ref count there. And these three below the definition of A and B. For the D-out entering. Using namespace thread safe. Oh, I should not be using that yet. Put that there. Then now, at the moment I include thread safe.h, A and B are already defined. So then we can use that. It should give the same error. Increment ref is a private member of const. So if I add a friend for this type. I lost my friend Sirat. This one. This should now be fully defined, and I do friend that thing. Wait, it's not fully defined because it's const unlock base, and we are in defining a const unlock base. Maybe that's why it doesn't work. Or should that work because it was a template before? But it's not a template when I do this, something like that. Oh no, this whole friend thing with templates is, can we say broken? I think even read writes is not defined yet. It's defined below this point. Yeah. Let's see where this goes wrong. Use of undeclared identifier B. I think I'm sure I did define B before we even include this, right? Oh. Instance tracker. Oh yeah, of course. I have to compile only the one that we are testing now, which is the unlock base test. No member name B in the global namespace. What? How? It's still... I'm compiling unlock base test. It is compiling utils instance tracker. Okay, I'm using a... yeah. No. Ah, very annoying. Yup, now I have to forward declare everything. At least read write. Maybe you can... Is that one already defined? I'm not even sure. Let's just forward declare the read write one. Oh, that's why I need to... I'm such an idiot. That's why we need to prefix with thread safe namespace. We're actually inside policy. So we declare a friend of for a struct, and that we didn't forward declare our stuff, then it's just going to put it in policy instead of in AI thread safe. Well, I'm glad I understand that now. Read write was now forward declared. Yep, and we don't know what that is. The read write mutex is not including anything. It's part of thread safe though, but it's not including any other header, so I can just include this. Before including the other one. Interestingly enough, I do get now increment ref is a private member. Of this copy. Oh no, first let's go here. VI that. And I want to know what the type is. So wait, a private member of that. I want to know where it is called from. In instantiation of memory loop. I think this. Constraint access unlocked base B. Let's happily read write, yeah. No. That's where it is defined, and we try to get access. I think from here. It's line 741. Yeah, this whole thread was nonsense, I think. It's mistaken. I need to add that one. Nevertheless. Oh, no template named unlocked base in namespace thread save. Yep, you have to forward declare unlocked base to get this to work. I have forward declared policy read write. We have declared or defined AI read write mutex. Your inside const unlocked base. I think I have forward declared this one as well then. Up there, let's move that down. Some forward declarations here. And then I need const read access sits in thread save. Yep. Or declaration required for const read access. No, unlock base. Okay. Yeah, now we have access, so that's good. So that means that what? Where's my friend? Here. That means that this friend Siret is not the same as this one. And it isn't, because this is, wait a minute. Yeah, it should be this one. Const read access. Const read access. Right, well, now let's make some shortcuts, because we have, I think, base is already equal to B. And I want to check again if I remove my friend, then it does not compile. Sure, at least it's doing something. And then we have here, I think, the policy mutex, right? Policy read write blah blah blah. Like that. So we can replace this with policy mutex. That should also work. So it should be the same policy mutex. Yep, and that is the case. Yeah. Also, now we know that the problem was the policy thing. I can remove this because that was an unnecessary paranoia. This should still work. Well, that means I think that maybe the C-red here is const read access of unlocked without the base. And then of course also without this base here, unlocked T. So I guess I have like a friend for unlocked A policy mutex instead of unlocked base B policy mutex. Now how the hell can I check that this C-red is that type? Well, first I can add it as a friend and then just try to get the same thing. Well, I think that that is actually this class. So C-red would be equal to this, which is not impossible because it compiles. And then I guess I should be able to do a static assert. Static assert for templates thing, yeah, well, why not? Then that is same C-red, comma, that type. Yeah, not equal. Static assertion failed for requirements and that is same standard thread const read access. Thread safe, const unlock base B, policy, blah, 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 comma, const read access, thread safe unlocked A. It's not equal. Sometimes it's testing of that, which is not equal. It's testing of that. Const unlocked base. Oh, oh, right. Hello. RQHZ BTW. Oh man. It's difficult. Hard to explain. I'm trying to figure out why this friend is not working. Sorry, why this friend is not working. And I think I can only understand that when I know what the C-red type is, so I can actually see that. And now I have an error where it prints that. But apparently now my C-red is equal to this, which is not equal to this. Unlocked. Const unlock base. Yeah. Well, yeah. Yeah. I think that this const here is stack culprit, which also explains why I only have the problem with the C-red. I think C-red is the only one that uses this const. But adding that worked. So why am I accessing it? Now I finally wake up. Why am I accessing it from const read access unlock base? Why am I not accessing it from const read access const unlock base? So I had expected it to be equal to A. Maybe so unlocked A. So maybe that's not the case. Maybe that is just not the case. Did I ever have a reason to think that? Let's test all possible types to begin with. Let's test all possible types. So we have static assert is same to unlocked A, or is same C-red, comma, and then this is always the case, and then we have an unlock base, I think like that. Base is always base, or apparently that one. Base policy mutex. I mean, if I get this to compile for all my for my whole test suite, then in every case it's always either this one, that one, or that one of the three. Yeah, oh, very awesome. And then there is another hope. A hope towards the solution that it is never equal to this type. That it is purely the problem with the const unlocked base and not the unlocked A. Yes, now we're getting somewhere. So this is the thing that is accessing it. This is the thing that we give a friend. Therefore it doesn't work. So now I could test, is it always this? I think it's always this. So it's never this. So I might as well say it is never that. And it is always that. It's kind of trivial. Might as well comment this one out as well then. It's just always this. Okay, whatever, make. Not even that compiles. So yeah, now we have the type. This is the type. And we need that one, but do we? Because it feels to me like a C-red should indeed be a const unlocked base. In other words, why am I accessing it from an unlocked base and not from a const unlocked base? So if now I comment this out, you get the error again. And then it says it's a private member in instantiation of member function. Const read access requested here, which is using unlocked base B. Yeah, this is using, yeah. Oh, yes, I get it. Well, maybe I could convert this unlocked to an unlocked, const unlocked, but yeah. Okay. So that is the reason. That is the reason. The reason is that a read access must use an unlocked base, not a const unlocked base. Why? Because a read access must be convertible to a write access, and therefore we must use an unlocked base. A const unlocked base is not convertible to write access. But then I use const read access base class just to have to type less or to avoid code duplication. And then that class is accessing stuff that it may no longer do because the unlocked is wrong. The unlocked type is not, well, what we expect for a const read access. What is the const read access doing? With my unlocked. It remembers the unlocked type. That's one thing. It allows construction, destruction, who cares? Accessor. Oh, I'm not going to access anything. Unlocked. It's being used to point to something. That should be, in this case, definitely the correct unlocked. So then the non-const unlocked base. Because I'm using this as a base class. Yeah, well then I have to give then I have to make a friend the other unlocked base as well. So not just C-red, but an explicit something else. What of these 4 declarations are still needed? Or which, I guess. IZHV? I'm afraid I don't. No. Refresh my memory. No template named unlocked. Unlocked base. So yeah, we do have need a 4 declaration for unlocked base. That would be this one. Well, you can say, you can tell me what you were talking about. I mean, now I have just 3 letters, ZHV. That's it. And no, doesn't ring a bell. But if we talked about anything and you mentioned that, I might remember it. I've always been bad at names to begin with. Cons read access needs to be 4 declared as well. So you also cannot remember what we talked about. You only remember that you have been on my channel before. Maybe you never chatted before. No, to do with the lost hunk. Kind of looks okay, except that this is commented out and I can then delete it or expose. No. No, I was trying to factorize large numbers, but I stopped with that. Because, yeah, well, nobody. It's just not possible. It's interesting though. So I had some fun. Good. But still didn't add any test really. Plus it's not working to begin with. But it's also not broken apparently. Not beyond what we had. This thing still works. It has been years and years and years since I tested, I have to admit. All those defines. Maybe I should do that before I make more big changes. So these two now work. We'll make. Apparently they do both. It's good. And what might be interesting to do is define the other defines, which is, where's my defines? I think it's start with test or something like that. Yeah, what is this? Conversions write to read access, and it's commented out. Should test it as well. But I'm going to test first I have a headache. That's not normal for me. Never have a headache. I can define test 1 and then that should not compile. How to do that? Test 1. Pose 1. Configure. No, reload. Resource. Configure. Doesn't do anything. But I'll have to edit this file, or probably. Does just this file. No. CD. What directory is this in? I think the object directory. CD dollar repo base object directory. That works. And then we run UCC cache, nah. Clang plus plus, all of that. That works. And then you can add a define just at the end. And then it says error, no matching constructor for initialization or food type. What? Test fail, error, no matching function will call to thread save write access. Thread save unlocked foo. Blah, da, 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 da. It's more or less what this said, but then differently. Shall I update the error as well? Well, that one worked. This should not compile, and it does not compile. And then we try test 2. Also does not compile. 422. No matching function for call to thread save read access. Test 3. Call to implicitly deleted copy constructor. Use the deleted function. Yeah, that is a copy constructor. 4. Maybe I don't even have to compare the error. If it's not compiled, then that's okay. No matching constructor for 436. I'll just replace whatever the arrow is. Cannot assign to return value. What is that? It's on the line that says test 5 fail. Assignment in read-only object. Cannot assign to return value because function returns a const value. I don't like the new error at all. 443. Six. Kind of the same thing. That's different. The previous one said something about private, but I think this is more modern. I just deleted the constructor instead of making it private, I guess. This 9. Yep, again private. There's 10. Test 11. Now, if only I was well versed in or what experienced in all kinds of test suits. I suppose there exist test suits that you can just put this in and then the test succeeds when it fails to compile. But yeah, doing this manually every 10 years is probably faster than learning how to use the test suite. I think actually I'm using CMake now. Before I think I automated this. Maybe. If I have had a make file. Seems pretty logical. Yeah, now it's time to finally start adding tests. The real tests that I was talking about. First of all, I really want to have a copy constructor for everything, and I don't want to work with references anymore. Everything must be a const reference. This is nonsense. Don't like that at all. Yeah, I have introduced now a const unlocked base, but I did not yet introduce a const unlocked. So the unlocked itself also should be split up into two classes. This is unlocked base. Do we have unlocked base? And then the question is, do we ever have an ampersand? Let's get a const ampersand. We have that, of course. And then if we remove the const, let's start at the top. Yeah, that's the return value of assignment operator. Move, assignment operator, move, assignment operator. Again a move. It's actually, we're already around 44%. Okay, well, that's so we don't. Oh, very good. But if I go to unlocked without base, wait a minute, unlocked const reference. Duh, don't have an unlocked const reference at all. Ridiculous. Now I have a lot of unlocked references. But what? What am I doing wrong here? So I'm not getting this. Yeah, unlocked. Oh, it says allow to template. Yep, okay. So let's instead look for template stuff. Yeah, just search for anything but closing brackets. Hopefully that works. So then we get that one. You can construct a const unlocked base from a const reference to an unlocked. It's the only bloody place where I have that. And if we remove the const, then cast unlocked base. So this unlocked base is not const unlocked base. It can be constructed from a non-const reference to an unlocked. And I think that's nonsense. But this doesn't work. Const cost is 40%. Okay, well, it's only 3 lines. That's nice. And I do want to have, do I already have copy constructors for, well, here's one, I think. Looks like a copy constructor. Const unlocked base, const unlocked base, const reference. That's a copy constructor. And then hopefully I'll also have that for the unlocked base. That's a move constructor. Do I not have a copy constructor? Maybe this one. I think that's copy constructor. Because the cons unlock base had a copy constructor. No, yeah, I can write my test. Yeah, the test exists of two things. The unlocked base is supporting boost intrusive pointers on top of everything. But I guess I can start with testing normal stuff. Is it not easier to add it to this? That's a fake mutex, this. Oh, that's a fake mutex. Yeah, these are all just test functions, right? To be able to peek under the hood if something is locked or not at that point. Okay, I have a test function that reads, just does read access. This one does read access, and then it gets write access. This just does write access. not so interested actually in those size tests. More interested in these things. Okay, I have an unlocked A with 3 different types of mutexes. These are real mutexes. And now we test writing. And then we test reading. So it works with the search. Okay. And then we do conversions, write to read access. So we take a write access, write it, and then construct a read access. And then, yeah. Well, I don't know why does it comment it out. Let's uncomment one of them. Ouch. This is a deleted copy constructor. On thread red. Yeah, I guess it's the same thing. I just don't allow that because it would require recursive locking. I think instead I should test creating a const reference. That should work. It's hardly a real test though. Same thing here and there. Conversions read to write access. I think for the one thread that is not a problem because it doesn't have a mutex. Let's see if this compiles. Implicitly deleted copy constructor of OT access. Copy constructor of OT access implicitly deleted because the base class OT access const has a deleted copy constructor. There. Why? Why would I not allow that? Struct one thread access const from unlocked. We do have an increment here, and that asserts that we are single threaded. Decrement here. Access the pointer to the unlocked. No reason to do this. Why would I disallow that? Anyone explain that to me? Hey Steve. No, not really. No. No. Well, my tablet or my phone, something simple is a waste time, but not on my PC or anything, or in serious way. Yeah, that. I just have the feeling that life is way too short for games. That is basically a part of it, I guess. My primitive access I cannot allow copying there. The one thread would not be a problem, but maybe it's not a good idea to allow it in case you want to convert afterwards to using a standard mutex. That could be an argument. Let's add that here. That reason. But that then means I think that I should support a watt cost, just like for the primitive case. Ah, now I have the feeling that this is also lacking. Shouldn't I have an OT const access as well as an OT access const, just like for the primitive case? Primitive being using a standard mutex or something like that. Let's see. Same thing here, right? This must be a const reference then. Cannot construct a new one. But in this case, this should work. It's a read write case. While it should not work if I try to use a what cost here. So do const reference is what cost, and obviously that should not work. Or I could make a what cost that does work and returns a by value a what type, and then I can use an auto. I think you can use auto here, like auto reference. I think the what cost returns a const reference, and this should work. But you must provide the ampersand here, right? To reference. So it doesn't really help, because in this case you have to just use auto, and if you use auto here, then it tries to make a copy anyway. So I'll leave it like this, I think. This should not compile. Did I already test that? I did. Great. Now I think that these are all of these things should also work when we work with a base instead of an unlocked. So perhaps I should move everything here to a function, and then pass variables. Could just pass three variables maybe. Let's call these things do access test, and then I'll just pass one thread primitive and read write. Pretty sure that I can just pass those as a const reference. Yeah, how far do we go? Wrapper, read access. I think that's a new test. Food type wrapper. So all of this, let's put that in do access test. Which then takes one thread and primitive and read write as arguments, whatever the types are. Well, I don't know what the types are, so maybe I should make it a template. Type name one thread, comma, type name, primitive, comma, type name, read write. Type specifier is required for all declarations. I'm having const reference there without type. Why? PRRW. No, what? Use of undeclared identifier one thread type. Yeah, that's just OT. I don't like it. Let me go back. Yeah, damn it. Yeah, I know. How to automate that? Hmm. Oh. Yeah, and that's what you get when you pass a const reference. Suddenly it doesn't work anymore. Should it work if I pass a const reference? No, I don't think so, because I'm changing it. Yeah, that's a big question there. That is a big question. So what is here an unlocked? And after constructing a what, I can read lock it. So I can write log it. Unlocked. Yes, it's derived from T. It's just it's a T. I can impossibly pass a const reference to that and then get write access, can I? Okay, to access const. Can be constructed from an unlocked const reference. But a const access, which then afterwards can be converted to an access, should not. So this change was wrong. dang, the change is wrong. I even committed it already. So you need something like this. Wait a minute, that's nonsense. Do we need a cast here? There's another one. We have access. Access doesn't no longer exist. Constraint access. Constraint access can also be constructed from a cons reference unlocked. And then an unlocked base. Wait, this is something else. Yeah, a cons reference, and then we have here const access, and we have a bit right carry. And read access. And right access. Actually, it looks good. Kind of looks good, actually. Yeah. The access cons against that, and then the cons access is that. Yeah, this is kind of double then. Can I not just use a using here? It's not really a big difference, I think. So we can do a using. Instead. And then the OT access, again, that's a cons reference to unlocked. And this one is then wrong again. And this one is correct again. To same thing. Delete. Move here. Delete. Move here. OT access uses const access OT const access, and this is an OT const access, which const and so on. I think that should work. Error type specifier is required for all declarations. So just like this with what, how, when, where. Args, and these are unlocked? No. What is it talking about? Wait. No. I have no idea what I'm doing here. Const access const. No, member named OT something. Using OT const access. What? Compile, damn it. Okay, well, no matching constructor initialization of unlocked what from in one thread. Correct. So now we must pass references here, otherwise nothing will compile. Well, we can construct creds from what? I'm not even testing creds. What kind of test suite is this? So incomplete. Just kidding, but no, not kidding. Too early. The cred tests should be tests as well. Writing, reading, conversions, write to read access. Yeah, I think I'm gonna copy this. Call it do const access test. Pass const references. And then do the read test, a pure read test, so reading again. Let's move that here. And we can call this at the moment that is actually 111, 222 and 333 inside of it, which is kind of here. So just do this test there, passing the same things. Moreover, I really need more C-red tests, I think. Oh, there are a few C-red tests here. I need a C-red as a function argument, I think. There's a lot of fails. Test failure test C-red access unlocked. Ah, yeah, they are. Is read locked? Yeah, well, it's not really doing a test. Now what? No matching constructor for initialization of type name unlocked red OT access from one thread. Blink, blink, blink. In instantiation of function template specialization do const. Yeah, no, indeed. Yeah, hello. Well, that was totally correct. I'm just being an idiot again. So this must be C-reds. Great. And then we can do the following. Or maybe you want to have a look at this as well. A wrapper. And a const reference or const wrapper. Things that should compile. Still quite a lot. Oh my god. Mm-hmm. So we have a wrapper here. Wrapper's actually unlocked these days. Unlocked foo. And I'm using a foo type for these tests. What is that? A foo type is defined as an unlocked of foo. Oh, and then I have to define change this macro in order to switch between read write and primitive. No, okay, well, yeah, nah. Do we really want to do that? Well, it's apparently some kind of required-ish because I didn't know what templates were. Well, no, this is thread safe, so I probably knew that. That feels kind of silly though now. Screams like just convert everything to a template so you can change the type of foo at will. I think that's exactly what I'm going to do. Is unlocked, is read locked, and the call is locked. It's the only thing we have, but that is because and primitive mutex is being called, which is bullshit because that's just the test mutex. Might as well is read locked, is write locked. make these things the same or not? Why not? Why not? Yeah, is read locked is the same as is write locked down below there. So I could do that. I don't have these then. Lock and unlock. Let's go for it, but then I want to first commit because it's a big change as usual. Like access to unlocked and main stuff. Whatever. Still works. This one also works, and I can just commit it, right? Can just commit it. Commit. Weep. Okay, and then step 1. I can call mutex. I have to do that anyway for the test that I'm going to do after this. So we replace all of this with mutex. And then of course mutex must be protected or something like that. Because we derive from it. It is protected, so we derive from it. We derive from it, I think, because we derive from the locked case. And then here you also have is read locked. It's now in terms of locked, but if I just delete that, then I must change is locked. I must have an, yeah, is locked must be changed to is read locked and is write locked respectively. Up here, so we have this. And that means that it's just read locked is the same as write locked. And then you have the same interface, and then we can do that. I'm gonna make this a template. And everything else. I think it's best to search for a food type. Replace all food types with templates. unlocked, then it requires a type name in front of it. Type name unlocked. Yeah. Loads of things are not correct here, but I'm going to see what happens now. Type name is redundant. Base classes are implicit types. Oh, excuse me. Error cannot form reference to the used class template specialization type. I think this is makes more sense. Okay, it became a template and it says I cannot deduce it myself. Well, it's simply unlocked. Probably need that built in other places as well. Then. Yeah, guys or girl, there's only one. I'm going to for a walk because I've been doing this again for like 4 or 5 hours. I need a walk. Going to buy a sandwich or something somewhere. Actually, it's dinner.